This animal should not exist. His skin changes color, but not for the reason you think. His eyes look in two directions at the same time, and his tongue moves faster than your brain can react. Scientists still can't fully explain how this works, and once you understand why, you will realize that nothing about chameleons is normal. We start with the color change. Here's what makes this worrying. When a chameleon changes color, its skin is actively restructuring itself in real time. Not like paint that changes like your bones that rearrange under your skin. Most people think it's camouflage, and yes, that's part of it. But the real reason is much stranger. Chameleons change color to show emotions, to communicate, to survive social situations. They have cells called chromatophores, tiny biological machines filled with pigments. When these cells tighten or relax, the color changes within seconds. But underneath, there are more layers working at the same time. Iridophores that don't just hold color, they bend and reflect light like a prism. Then research shows that a chameleon can produce up to 30 different shades, not random colors, specific signals. When a chameleon feels threatened, bright, aggressive colors explode across his body to intimidate enemies. Comfortable or looking for a partner? Soft, warm tones that say, "I'm safe, come closer." They don't hide, they talk with their whole body, in a language that we are only just beginning to decipher. But this skill comes at a price. The color change isn't just visual, it's connected to their emotional state, temperature, and even light exposure. Scientists have found that when a chameleon changes color, its entire physiology changes, heart rate changes, hormone levels spike. The nervous system fires off patterns that we still don't fully understand. It's not just superficial, the whole animal changes. And here's where it gets even more complex. Different species have developed completely different color palettes. A panther chameleon in Madagascar can show electric blue and radioactive green hues. A veiled chameleon exhibits earth tones and muted patterns. Why? Because their environments determined which colors were useful. But recent research shows something unexpected. Chameleons can see colors that we can't. They perceive ultraviolet light wavelengths that are completely invisible to humans. This means that when they look at each other, they see patterns and signals that we literally can't detect. Scientists believe that these UV patterns help them identify potential mates, recognize rivals, and navigate their territory. It is a hidden layer of communication that takes place right in front of our eyes. And we're just starting to crack the code. Now let's talk about their hunting technique. Have you ever seen a chameleon catch its prey? It's like magic, but the reality is even more disturbing. A chameleon's tongue can stretch twice its body length. But here's what scientists didn't expect. It launches in 0.07 seconds, faster than you can blink, faster than most high-speed cameras can capture. The mechanism behind this is biological madness. The tongue is not just a muscle that stretches, it's a catapult system, a complex structure of accelerator muscles wrapped around a core of bone. When the chameleon lets go, it's like a crossbow is firing. The muscle that powers this contracts 300 times faster than human muscles. In comparison, the muscles of an Olympic sprinter shoot quickly. The tongue muscle of a chameleon makes that look like slow motion. Gets even stranger, the tongue can tackle prey up to 10 meters away. That's not just accuracy, that's ballistic computation that takes place in a reptilian brain the size of a grape. They are not just any hunters, they are biological snipers. And the speed isn't just for show. Chameleons can catch insects in flight, dragonflies, flies, even moths that actively evade. This makes them one of the most efficient predators in the animal kingdom. This is where the explanation falls completely. Chameleons can move their eyes independently, one forward, one backward. Two completely different goals follow at the same time. But their vision isn't just multifaceted, it's strange. Each eye works on its own. Separate focus, separate tracking, separate processing. It is as if two different creatures are looking out of the same skull. When a chameleon spots prey, both eyes suddenly focus on the same target. This gives them depth perception that is so precise that they can calculate distance to the millimeter. This way they know exactly when to fire their tongue, but the visual system goes deeper. Chameleons see in a color spectrum that is far beyond human human capabilities. We mentioned ultraviolet light, but they also look at ranges that help them detect temperature differences, moisture levels, and even the health of other chameleons. They don't just see shapes and colors, they read data. And scientists believe that this is why they have developed such extreme eye mobility. When you can see so much information, you have to scan constantly. But here's what researchers have recently discovered. When a chameleon hunts, one eye follows prey while the other eye searches for predators. They fall and defend at the same time, in real time, without loss of accuracy. This level of multitasking should be neurologically impossible. For context, human conversation takes place between 85 and 255 Hz. The music varies from 20,000 to 20,000 Hz, something outside that narrow range of 200 to 600. They just don't hear it. A chameleon cannot hear birds singing, the wind rustling through leaves, or the sounds of most predators. So how do they? When a predator approaches, they don't hear it coming. They feel the vibrational signature, the rhythm of steps, the frequency of movement, and they know exactly what kind of threat it is. This is not a disability. It's a totally different way of seeing reality, and it's more effective than hearing in their environment. Sound is muffled by dense vegetation, but vibrations, they clearly travel through branches and leaves. Scientists are still trying to understand how their nervous system processes this information, because the level of detail they get from vibrations is equal to what we get from hearing. Now let's talk about how they move. You would think that an animal that is so strange would also move strangely, and you'd be right. Chameleons move like leaves, swaying in the wind, slowly, purposefully, almost hypnotically. Every step is calculated, every movement mimics natural vegetation. It's not inertia, it is camouflage through movement. Prey animals pay attention to sudden movements. Predators scan for speed, but something that moves exactly to the rhythm of windblown branches, invisible. Their feet are perfectly designed for this. 2 toes point forward, 3 point backward, like biological pincers that grab branches without slipping. They can cross thin branches without rocking them, can climb vertical surfaces without making noise. You can traverse an entire tree roof without warning anything underneath. But here's what most people don't know. If they are threatened, they can sprint, not far, just enough to create distance. It is a short, explosive eruption that completely catches predators by surprise, and they freeze. Full suspension, the heart rate drops, breathing becomes invisible, and they disappear into the vegetation as if they had never been there. But if freezing doesn't work, they have a backup plan that is purely psychological warfare. The chameleon suddenly inflates its body, making it look twice as big, opens his mouth wide and reveals a bright interior, starts hissing loudly, a sound that is surprisingly far. And the colors? They explode in the most aggressive pattern possible. Black, red, bright, warning colors that scream danger. A slow animal that can scare a predator. It shouldn't work, but it does, because the sudden transformation is so dramatic and unexpected that predators hesitate just long enough to let the chameleon escape. Studies show that this defense mechanism is successful against natural enemies such as birds and snakes more than 60% of the time. And scientists are still studying variations that seem impossible. There are more than 200 species of chameleons. Each of them has developed bizarre adaptations that push the boundaries of what should be possible. Take Jackson's chameleon, 3 horns on his head, like a miniature triceratops. These aren't just for show. Males use them in fights for territory and mates. They get into each other's holes and try to push each other off branches. And these chameleons live in cold mountain areas where most reptiles cannot survive. Temperatures that would knock out other lizards. Jackson's chameleons thrive there. Their color change is more subtle, but their cold tolerance is extraordinary. Then there is the Bruchisia, the leaf chameleon. Some species are smaller than a matchstick. The smallest is barely an inch long. They don't live in trees, they live on the forest floor, camouflaged as dead leaves. Their skin texture mimics dried leaf veins. Their body shape is angular and flat. You can stare straight at it without seeing it. Unlike their tree-dwelling relatives, they have lost the ability to produce bright colors. Instead, they have perfected earth tones and texture imitation. At the other extreme, Parsons chameleon. up to 75 centimeters long, huge compared to other species. These giants move even slower but have developed incredibly patient hunting. They wait motionless for hours until the prey comes within reach. Each species solves the same problems: survival, reproduction, hunting, with completely different biological solutions. Scientists study these variations to understand how evolution produces such extreme diversity, how one ancestral line can split into 200 species, each more bizarre than the last. And most of these species evolved in Madagascar, an island that became an evolutionary laboratory for chameleons. So here's what we still don't understand. Why are their colors so diverse and extreme? We know the mechanics, but not the full evolutionary pressures that have caused such complexity. How does temperature affect their behavior in ways we haven't measured? Recent studies show that they respond to temperature changes that we can't even feel. What does their skin actually do when the light is restructured? The physics behind iridophore manipulation is still being investigated. And the biggest mystery, how did all these systems evolve together? The independent eyes, the explosive tongue, the vibration-based detection, the color-changing skin. Each of them alone is extraordinary. All in the same animal? That is almost impossible. But chameleons have been perfecting these adaptations for 100 million years. Offspring of ancient lizards that learned to survive in ways that nothing else could match. Nothing about chameleons is accidental. Nothing is normal, and that's exactly what makes them one of nature's most perfect designs. So the next time you see a chameleon, remember, you're looking at an animal that has rewritten the rules of what reptiles can do. What surprised you the most? The tongue speed, the deftness, the restructuring of the skin, the battle horns? Let us know in the comments, because the mysteries of science run deeper than you think.